Thanks for joining, everyone. We'll give it just a minute or two just to let some people, the last bunch of people join, and then we'll go ahead and get started. All right, thank you all for joining today's Chit Chat research. I see some familiar names from our previous events, so welcome back to those who have already attended some of our SafeGraph events. If you're new to the community, glad to have you with us on today's event as well. So just a quick introduction for those that I haven't interacted with before. My name is Nikki Kazahaya. I'm one of the community managers here at SafeGraph. If you are interested in inviting your peers and colleagues to the SafeGraph community so that they can attend events like these, I will post a link to join here in the chat in just a couple of minutes. It's a free Slack community for data enthusiasts. You'll get access to our support team. You'll be able to share your work and connect with others in the data science community. So before we get started with today's session, just want to keep a few things on everyone's radar. We do have another event coming up next week, a week from tomorrow, Friday, August 13th at 1 p.m. Pacific or 4 p.m. Eastern. We'll be doing another fireside chat event with a new speaker, David Rothschild, an economist at Microsoft Research. If you're unfamiliar or haven't attended our fireside chats in the past, it's usually a 30 to 60 minute Ask Me Anything session. Like all of our other events, it is free to attend. So if you're able to make it out next week, certainly recommend coming out for that one as well. Hope to see you there. So before I introduce today's speaker, I always like to go over the format for these sessions for anyone that's new. We always love when attendees ask questions. I'm going to pass off the baton here in a second. So if you have questions that come up, don't feel obligated to hold them off until the very end. You're always welcome to raise your hand, drop them in the Q&A box or the chat. I'll keep an eye on all three of those platforms as they come in. And if you feel comfortable, I'll have you share your audio and video, and we'd love to have you ask the question live. So with all of that said, I will go ahead and introduce our speaker, Unnati. Unnati is an assistant professor of business administration and marketing at the Gies College of Business, University of Illinois at Urbana-Champaign. Her research lies at the intersection of mobile marketing, consumer mobility, and engagement in digital environments. Specifically, her research examines how consumers' use of mobile apps affects their behaviors in online and offline retail stores. She also studies how consumers' movement patterns predict their future retail visits and the impact of new forms of mobility. For example, e-scooters for both consumers and retailers. She uses causal modeling, econometrics, machine learning, and deep learning approaches to examine these research themes. Unnati's research has been published and accepted at Marketing Science and Journal of Marketing Research. Her dissertation on mobile apps has also won several awards. So thank you so much for hopping on today. At this point, I will pass things off to you.
Thank you for that introduction, Nikki. I'm so excited to share my latest research with you and our attendees. I'm going to share my screen, and if there are any questions, like Nikki said, feel free to direct them to me during this conversation. As much as possible, we'd like to keep it interactive. So let's begin with that. So this project is, a new initiative where we're trying to learn from consumer movements. But as you can see from the title, we're very interested to learn as firms and researchers, what can we see from driving patterns that's new about consumers? So specifically, we'll be using individual driving behaviors to predict their retail visit pattern, but then also go beyond this business question to really understand the policy implications of tracking these types of granular data. So why do we care about driving? So, this project is a collaboration between me and my co-author, Fernando Luco, who is an economist at Texas A&M University. And when we started noticing some of the behaviors of consumers around us, one of the things that stood out is how many miles of driving per year are taking place just on US roads alone. But really, aside from the miles driven, what's really new in the last few years, last couple of decades, is that these data are now being tracked by consumers' mobile devices. So most brands today, most retailers, and I know there are some retailers joining us today, have some kind of way of tracking consumers and their location using their mobile apps or mobile data. If they're not doing that, then there are also third-party aggregators, including SafeGraph, which can make available these granular patterns of consumer movement, which were not really observed until a few years ago. So what we're trying to do in this project is learn from those behavior, because as we can clearly see, there's huge amounts of billions of dollars being spent on location marketing. So before I begin, I want to encourage you guys to think about this. So clearly, location data has some advantages for firms, but can you maybe type in the chat one or two reasons why this type of location data may be potentially concerning? What could be a potential downside that you in your research or your practice as a retailer have seen the potential downside of collecting granular data? Let's see if somebody can type in the chat.
Awesome. We will give people a couple of minutes. Curious to hear everyone's answer.
Yes. What are some potential concerns of tracking consumers in this way? Is anybody working with location data? I'm also interested to see.
Oh, yep, some great answers coming in. Maybe they don't all opt in to being tracked. Every track is not meaningful.
Perfect. So people maybe do not want to opt in to be tracked, and then every track may not be meaningful. By that, I'm assuming that some of the location data may not be very precise. Maybe you're just tracking them when they're at home or at work. It doesn't really matter for business purposes. So very good. That's kind of what I'm hinting towards, the specific challenges that you have captured already in your responses. But the big one that both of these that you described fall under is just this notion of tracking can lead to some privacy concerns for consumers as well. They may not want to be tracked. Maybe they don't want to be tracked in specific locations. So while businesses can gain a lot of value from these types of granular data, there's also a potential downside that, as you guys have said, of potential privacy concerns. They may feel invaded. Particularly, apps often ask to be tracked while they're not even using it. So consumers have these days 2 or 3 different options. They can either only be tracked while using the app, or the tracking can be always on. So depending on the level of tracking, again, consumers can feel threatened. But another potential concern can be from the regulator side. For those of you who've been following the news, GDPR has affected businesses in really big ways, and the Consumer California Protection Act has also been very, very influential in how much consumer privacy should be preserved by businesses. So again, from a regulator perspective, it is important to not engage in any practices which can threaten consumer privacy. So with that, the objectives in this research are twofold. First, from a business perspective, we do want to learn what can driving data teach us over and above traditional metrics like demographics or past visits to a retailer about consumer behavior. The second question then is, how can we quantify the granular data tracking versus privacy trade-off? And is there a trade-off? So those are some things I will talk about, but very interestingly, we'll use individual level consumer data to do so. So let's see what already has been studied in this field. So I'm a marketing researcher. In marketing, there's some work on consumer location and coupon redemption. Particularly, there's some papers that have looked at the effect of crowdedness or consumers' walking path in a shopping mall using mobile devices. How do those impact which retail stores consumers will visit or where they will redeem a coupon? They typically look at very immediate coupon redemption in a causal setting. There's also been other works which directly look at this question of privacy, particularly the impact of privacy laws on businesses and their advertising effectiveness. And finally, there's some deep learning and machine learning papers that are now also trying to look at unstructured data such as text and images and try to learn consumer behaviors from those. So what we're going to do in this project is also propose a deep learning model which can understand full driving trajectories of a consumer and really extract information that is useful. So this paper, just to narrow down on what exactly we're doing when juxtaposed against what's been done before, we are now using individual level driving behaviors in addition to traditional metrics that marketers have been using in the past in order to see whether consumers will visit certain retailers or not. The second question where we're going to be evaluating predictions for different hypothetical privacy regimes. So what happens if a retailer, for example, cannot track consumer at very granular frequency? So we would then estimate the value of that data under different counterfactuals. And finally, we will propose a new algorithm for a hybrid CNN LSTM model, which will then take into account really complicated spatial and temporal nature of driving data, because driving data, although useful, can be very challenging to work with. So in this model, we're going to be able to take snapshots of driver trajectories and then learn from those in terms of the retail behavior and visits. Okay, so the data is something I want to talk about a little bit more because these questions are quite ambitious and we need the right kind of data to study this. So the way we collect our data is from an app, which is based out of Texas. It's a safe driving app, which currently covers about 200,000 users. For my application today, I'll show you the results from a small 5% sample for now, and we're still scaling up these models. The interesting part about this app is that it constantly tracks consumers and rewards them points for every mile of safe driving. So if they're not using their phone while driving, the app rewards them points that can then be redeemed at partnering retail stores. What kind of data do we observe from this app? We have individual level data about the consumers. So for instance, the demographics, and it's from a small college town in Texas and also Houston and surrounding areas. So we do observe that an average individual in our data set is 32 years old, 65% tend to be female. And what's interesting is we observe their driving trajectories. So think of a data set, a spreadsheet with geolocations and timestamps of everywhere they've been, which is captured every 3 minutes. So we have very granular, high frequency data about their driving with over 450 million plus GPS coordinates. In this data set that I observed for 2 years, I see customers on average driving about 405 miles, making 158 stops and 9 restaurant visits. I also then combine this data with SafeGraph data, and that's how I got to know more about SafeGraph, because the GPS data itself doesn't have visits identified. So I cannot see from the driving data where people are visiting a retailer. So by using the SafeGraph polygons and geometry data, I can then identify for every restaurant in Texas where there was a visit or not by overlaying it with my driving data. So that's the unique way in which we're combining these two data sets. So this is what a typical driving trajectory looks like. So these are two consumers from our data. The one on the left, as you can see, on a given day is driving through a series of points. The black dots that you see in this figure is any time the consumer stops for more than 10 minutes. But as you can see, some of them may not be meaningful, as one of the attendees pointed out, but we do notice that there are 2 stops this consumer makes, which are at specific restaurants. So first, maybe they stop at Outback and then they go to Chick-fil-A. Now, what's interesting is on the same day, if you look at another consumer's behavior on the right side panel, you would see that this consumer's behavior not only is a driving trajectory much more different and longer, but they also stop at very different kinds of places. Perhaps, their visits are even correlated. So you may stop at Taco Bell for lunch and then go to Brooklyn Cafe for a coffee right after. So the interesting things about these trajectories is that consumers can drive in very different ways and stop at very different types of locations, but also that these visits may be coordinated and correlated in some way that just observing where somebody went in the past may not fully capture. And that's the intuition behind why we even care about using these driving data to really elicit consumer preferences for a restaurant. So the prediction problem in a nutshell is going to be, given a consumer, will they visit a particular restaurant or not in a certain time period? And so that's what's going to be central to our prediction. Now, while driving data can be immensely useful, as we've seen, it's full of challenges to even try to model them. So for the rest of the presentation, before we get to the results, I want to talk about 3 specific challenges of working with these types of driving data. The first is just extracting driving features. So you cannot easily input a full trajectory into your model. So what can we do to extract some meaningful features? And I'm going to describe our approach for each of these challenges. The second is going to be similar to what I said earlier. The driving data won't already come with labeled visits. So it's super important for us as researchers to be able to identify when there is truly a visit by the consumer. And finally, the spatial and temporal correlations can matter a lot in this setting, along with consumer heterogeneity. So we're going to find a deep learning model that can handle those dimensions really well. So let's jump into the first one. And I'm about to show a plot which always throws people off. So be patient with me as I explain what's going on here. So extracting driving features, if you see in the middle, you see this projection. So as you can see, this figure has no dimensions. The X and Y axes aren't labeled. Think of it as a projection into a multi-dimensional space. So we have, say, 20 different features about people's driving. When I say features, these are things like how far they travel, how many stops do they make, how often do they stop, more technically, what is their radius of gyration or entropy in their driving, which is how much do they break away from their predictable routine driving patterns. So here, what I'm showing you is a projection in that multidimensional space. Each point is a consumer, and the color code, the color basically represents one driving feature of that multidimensional space, which in this case, I'm showing you entropy. So how much they break away from their routine travel patterns is an intuitive way to think about it. So we go from dark purple, which is very low entropy users, to green, which is very high entropy users. If I were to project any single person onto just a map of what they're doing, you can see the purple people are kind of very close to their home or wherever they're hanging out. Those are typically the same kinds of locations if you do a heat map. But if you look at the one in the bottom, this person is all over the place. So maybe they're making, a lot of trips out of town. So from Houston, College Station area, they seem to be going towards New Orleans or Louisiana. So you can clearly see that these driving features vary a lot based on where the individual falls in that projection. So we want to explore this a little bit more, because what seems to happen is if I color code it by different driving features, individuals seem to cluster in a different way. So all the greens are more towards the left in radius of gyration, but if I look at their entropy, the clustering is in a different way. So this is an example of how we do our feature engineering in a very intuitive way by extracting things like radius of gyration or entropy, for which we draw a lot on computer science and even physics, for that matter, to understand people's mobility patterns. The second challenge we face is identifying GPS visits from the location data. And this is where SafeGraph data has been a huge help for us. So what we do is we take the geometries provided by SafeGraph for every single restaurant in Texas. And anytime we see a consumer's driving pattern in terms of their driving, they stop within any of these polygons, we consider that a visit if it's a stop over 10 minutes, but under about 2 hours. So that's how we define visit. Of course, we can use many different definitions of visits, but that's the typical amount of time we see people spending at a restaurant. And so just by overlaying, as you can see in this figure, you can highlight these different locations and see if people are stopping there. Now, one challenge with this, as some of you may already be thinking, is if one location is within another location. Say there's a Starbucks inside Target. those are locations our data cannot currently capture. So we may be underestimating a few of those visits where people are going to a store within a store. So for now, we are excluding those. But if there are any questions, I'm happy to answer. Okay, so before I jump into challenge 3, I want to show you some early results. I know people are like, okay, enough about challenges. What's happening with the data? So here, I'm going to show you some quick prediction results, but there's a couple of intuitive findings we get from just running our baseline models with all of the data. So for a given restaurant, here I'm showing you results for Mad Taco, which is a popular Mexican food restaurant in Texas. What I'm showing you here is different models with different feature sets. So in the first model, what I'm showing you is if we only used people's driving summaries, so things that I showed you like radius of gyration, entropy, if I just use those features, our model is able to predict with 69.9% accuracy whether they will go to Mataco or not. And remember, the benchmark here is a 50-50 random chance. So if I just threw in some random data, my model would have an accuracy of 50%. So just using the driving data already, we can see it's doing way better than a random prediction. And again, this is for a test data set. The numbers I'm showing you, the model has already been pre-trained on a training data set. So those are two important things to remember when interpreting these numbers. The second thing I want to talk about is the accuracy. If you just focus on the accuracy for a minute, you will see that when we add on demographics to the driving data, which is the most typical measure used by marketeers for targeting or segmenting, we don't really see much of an improvement. So the model is not a whole lot better off by simply throwing in age, gender, and other things. But when we add in their past visits, which is describing whether somebody has been to Mad Taco in the past, in that case, there's a huge 10% jump compared to just having driving data. So what this tells us is that capturing past behavior or past preferences is much more meaningful in this context. And of course, the model that seems to perform really well on the test data set is the one with all 3 categories of variables. Nikki, are there questions?
Yes, there are. And I'm sorry if I disrupted your flow. I also made your co-author a panelist as well. So Fernando, you're also up here as well. A couple of questions. So we have one question from Jeff. Let me see if I can let Jeff talk.
Hello?
Hey, Jeff, go ahead.
Yeah, I mean, this had to do with your previous slide, but I was curious how you actually merged the GPS data with the polygon data. So like, was there a buffer away from the polygon? Because I imagine it wasn't a straight intersection because the cars probably didn't drive into the building. I was just curious.
Yeah, we look at the closest point. That's our best way of doing it. So that's why it's a little difficult if it's a store within a store. We don't know for sure. If somebody parked really far away, we wouldn't know for sure. Those are just some limitations where we can't for sure say it's a visit because we do look at the minimum distance.
Minimum distance to the edge of the polygon.
Yes.
Got it. Thank you.
Great question. Thanks,
Awesome.
Jeff.
We have one other question, Alejandro, if I'll allow you to talk, if you'd like to unmute yourself. All right, it looks like you might be having some issues. So Alejandro's question was, when predicting restaurant visits, what happens if only past visits, no driving is used?
That's a great point. I think we get close to 70% in that case also. So past visits without driving, if I remember correctly, was very comparable. But demographics alone wasn't, as you can see, wasn't as useful. So those are the numbers I remember.
Awesome. Thanks so much for taking those questions. I'll let you get back to it.
Thanks, that's super helpful. Okay, so the other point I wanted to make on this slide is that we're using a separate set of data in terms of who the users are to learn on the training data set, and then predicting for a very different set of users. So in that sense, that's why we use the word learning from their driving behavior, because it's really telling us how we can learn those patterns and predict for a different time period for a different set of users. So those are some intuitions behind these results. And as you can see, we also care about precision and recall, because we don't just want the overall accuracy, we also want to make sure when there is a positive prediction, it truly is a true positive and not a false positive. So as you can see, by adding driving data and past visits to the driving data, we seem to do really well on those precision and recall parameters also. Okay, this is just more visually seeing what happens as you add on more information to the model. As you can also see, and I think this kind of goes back to Alejandro's question, past visits to a brand, if you look at the importance of each variable to this prediction model, past visits to the brand does seem to be one of the most important and intuitively highest predictor of where people are going to go next. But if you look at the remaining features, most of them are coming from our driving feature set, except maybe the 10th one is gender. So we do see the same kind of patterns here. Perfect. So these are not, next I want to show you some results on our second research question, which you're very excited about. So what are the privacy trade-offs of having this type of granular tracking? So what I'm showing here is for the model with all the features, driving, demographics, past visits, what happens if we take away some of the frequency of data? So instead of having driving tracked every 3 minutes, we track driving only at half the frequency, so every 6 minutes. And so what we see is accuracy falls drastically. Instead of the 80% we were getting for the test set earlier, we're now only getting a 66.6% accuracy on our predictions of whether a consumer visits Mad Taco or not. And this tells us that there's a huge fall in prediction accuracy, and that's coming both from precision and recall. So we're doing worse off in terms of making those true positive predictions. And so the point here is that there is a trade-off between privacy and the value of the data tracking to a business. However, what was interesting is when we went on from half the frequency to cutting it even more, say only using 1/3 of the data or a quarter of the data, we didn't see much fall after that. So the kind of the silver lining here is that if you're willing to compromise a little bit on prediction accuracy, you may be better off than tracking consumers less and less, because at a certain point, there's a threshold beyond which tracking them less won't affect your prediction accuracy much more. So those were some interesting results, which really surprised us. I'm going to try to summarize everything so we have more time for Q&A. In all, this project seeks to look at the behaviors of individual drivers and learn about their retail preferences from them. Specifically, we show that adding on driving data or mobility has huge advantages in terms of prediction accuracy. So what we focus on here is that we can model this highly unstructured driving data for predicting retailer choice. We also show that when tracking people in a less granular way, we have 7 to 13% loss of prediction accuracy across different models. We've tried Lasso, XGBoost, Random Forest, and we see the similar result consistently across different prediction models. We also show that there is a win-win for firms and consumer, because after this half data, when we reduce it even more, there isn't really a loss in prediction accuracy. And so the implications really from this research are twofold. First, for managers and retailers, driving can allow them to learn about consumer preferences and predict visits fairly accurately. The second implication is for researchers, because we've seen that driving data are very, very underexploited, and they've only become available in the last few years. So there's a huge potential to include these whenever we are trying to learn about consumer preferences. And finally, from a regulation standpoint, it's useful for regulators to know and manage their policies towards privacy. So if there are other questions, I'm happy to take them. In terms of our next steps, we're now looking at incorporating these full trajectories instead of just the last visit or just the summary metrics by using a CNN LSTM network, which we're now working towards. So I look forward to your questions, and thank you so much for attending.
Awesome. Thank you so much for going over some of your research. Always love hearing about what people in the community are working on. We'll give everyone just a few minutes. It usually takes a couple minutes for people to post questions. Let me see here. It looks like Fernando was able to answer one that came in as well, so thank you.
Perfect. I think somebody asked what kind of model is used. Balakumar. So we use different, like I said, different prediction models. The one I showed you was a lasso, but they were all very similar in terms of their prediction accuracies. Did I miss any other questions, Nikki? Anything you got?
I believe those are everything from my end. Anybody else have any final questions before we wrap up today?
And then I
looks like
know that there are people who are working in mobility or micromobility. So if anybody wants to reach out to us, our emails are on the slide. We would love to hear from you.
awesome, and I'm also happy to connect anyone after this event as well. It looks like Jeff has a couple more questions. So did you have any concern with predicting driving-based with predicting driving-based visits using driving-based metrics like entropy, i.e. Both are derived from the driving data?
Yeah, that's a great question and something we thought about a lot. So the way we handle that circularity is that the learning over the driving data is happening before the period of the visit. So we use data from August 2018 till August 2019 to learn from the driving behavior on a different set of users. And then we predict for September and October. So in that case, we're separating both the time period and the set of users. So it's not just a mechanical prediction, like if you're slowing down, obviously you're going to visit. It's a completely different time period.
Awesome.
Yeah, I should have made that clear. Thanks, Jeff.
All right, any other questions for our speaker today? Also, Fernando, thank you so much for joining. Also, if you have any comments as well, you're welcome to share those as well.
I think nothing was super clear.
Awesome. So one other question. So can you say it's characteristics of the driver's driving behavior predicting their future behavior of visits?
It's characteristics. Yeah, I think characteristics, I guess I'm not sure what you mean. It just seems like the same features. Okay, got it. So you're asking what is the intuition behind these driving features? So I think things like entropy, radius of gyration, these are just ways of capturing human movement. Ultimately, what they're telling us is how much do you deviate from your regular driving pattern? So for instance, if I'm somebody who's always working 9 to 5, you'll see me drive, say 8:30 to 9, 5 to 5:30. But if I'm somebody who is working, freelancing, or doing a lot of more traveling outside the city, then you may see my driving patterns as being much more variable over the course of the period you track me. So that's kind of the intuitive way of thinking about entropy. And I think that's helping us predict people's behaviors, because maybe somebody with a more predictable, regular pattern would stop at more predictable, regular locations, but somebody who is driving these one-off trips here and there, or is harder to predict, is harder to figure out where their restaurant visits are going to be. Fernando, do you want to add to that?
Yeah, so I think one of the key things that we're learning with these is how much each type of data, each type of structure is bringing to the table. And that's something, for example, like when Unati was talking about past visits, that's talking about consumer preferences. Well, all this driving data, what that is doing is talking about driver heterogeneity, and to what extent like the preferences for specific categories or specific types of restaurants relate to this consumer heterogeneity on other dimensions. So basically what we're adding is trying to figure out like how much of this is coming from each of these different data structures.
Yeah, that makes sense. And I posted a paper from Nature in the chat window that we draw from heavily. And it's titled Understanding Individual Human Mobility Patterns. And they've done a lot of work on just the math behind some of these terms as well as their intuition.
Awesome. Doesn't look like we have any other questions. Let me just double check here.
Yes, I can send it to all attendees. So if anybody else is interested in the driving metrics, feel free to look at that paper.
Awesome. Well, if there's no other questions, I think we'll wrap things up for today. Thank you everyone for hopping on. Like Unnati and Fernando mentioned, they're always wanting to collaborate and connect with others in the community. So if I can get anyone in the community in touch with them, certainly feel free to reach out to me. I'd be happy to do what I can to facilitate any collaboration. So
Yes.
Otherwise, just a couple other final reminders. We do have a fireside chat next week. Like I mentioned at the beginning, I just dropped the link for that as well. If you're able to come out, we'd love to have you. Otherwise, I will reach out to everyone after this event is over. I'll blast out a recording in case you want to share it to other peers and colleagues, or if you'd like to review what we talked about today. But otherwise, have a great rest of the week, everyone, and take care. We'll see you soon.
Thanks, Nikki. Bye.
Bye.